Lesson 2 lab. It simulates ramen cooking with 5 chef threads, A, B, C, D, and E, 4 shared burners. And here are my imports. I import the random for the random preparation times, which would be 1 to 2 seconds. Import scanner to read the number of ramens from the console. Time unit for sleep methods. Atomic integer for the integer types. This is my main class. And then the number of available burners is 4. Number of chefs is then threads A, B, C, D, and E. And then we have a monitor object, a shared monitor object for the synchronization. An array tracking which chef uses which burner. And then we have how many ramens are still needed to be cooked. And then for the order counter, it's used to generate the line numbers. And for the static initializer, and we'll run it once when the class is loaded. It'll loop through the burners and mark it as free. Then we create a scanner to read from the console, ask the user for how many ramens, read the number, store the value in the thread safe counter. Then we close the scanner. Then we print the border. And we create a scanner, or a thread for each chef. Calculate each letter. 0 is A, 1 B, 2 C, etc. And then we start the thread with lambda. And for the method, we have the code for the one chef thread. And each one has its own instance, random instance. And it'll continue while there's still ramens to cook. Generates a random prep, 1 to 2 seconds. And it'll sleep for however many desired seconds. And then we'll reset, which would mean that no burner is required yet. And then it'll only go 1 thread at a time. And it'll recheck under the lock and exit if it's a loop. Then we search for the first free burner slot, and if we find it, increase the line counter, assign the burner to the chef, and decrease the remaining orders. And then we'll take a line, and then print on the line. Show the burner occupancy. And then if you successfully get a burner, we'll cook for 2 seconds. Then we enter the second section to release the burner. Print a line. Free the burner and update. And then we find the first free burner index, check the burners from 0 to 3, If the slot's free, it returns to the index, and there's no free burners found. And then we print the current burner usage, and then build the output, loop through all the burners, and add a space between the burners.